Finally, we are here in the modern Thuraya Planetarium, proud of the Qatar. Here we can explore our galaxy in the most realistic and amazing and effective way. Let's go and check it out. Okay, let's start. Space shuttle NASA. Exactly. Behind of me, spacesuit of NASA, and I will show you some information about NASA, about first astronaut, and so on. NASA, or the National Aeronautics and Space Administration, was created by President Dwight Eisenhower in 1958 in response to the Soviet Union's launch of the first artificial satellite the previous year. President John Fitzgerald Kennedy gave NASA the goal of sending a man to the moon by the end of 1960s. On July 20, 1969, the first man walked on the moon as part of the Apollo 11 mission. 20 people walked on the moon, all during the Apollo missions. In 1970, the Apollo 13 lunar landing was aborted after an oxygen tank exploded. Space Shuttle Enterprise was the first shuttle built for the reusable spacecraft fleet, though it was created for testing and never flew in space. The Space Shuttle program has had more than 120 successful flights, but also 2 disasters in which the shuttles and crews were lost: Challenger in 1986 and Columbia in 2003.
So what happened to Sputnik? After it was launched, Sputnik continued to broadcast its incessant beeping for 21 days until the onboard transmitter batteries ran out on the 26th of October 1957. Although it stopped broadcasting, Sputnik could still be tracked, and despite its lack of sensors, this tiny satellite still returned some valuable data of the Earth's upper atmosphere. Sputnik's orbit almost immediately began to decay, which was planned by the way, and on the 4th of January 1958, Sputnik burned up as it re-entered the Earth's atmosphere. This tiny, highly polished sphere had survived 3 months in space and completed 1,440 orbits of the Earth and travelled over 70 million kilometres while doing so. The only surviving piece of Sputnik is this metal arming key. It was used to prevent contact between the batteries and the transmitter before it was launched, much like the plastic tags you find in new electronics. This key is currently on display in the Smithsonian National Air and Space Museum in Washington DC, and there is no doubt there will be a replica of Sputnik in a science museum near you.
At 5 p.m. First show starts. On the screen for kids, some kind of cartoons about galaxy and so on. 12:30 a.m. already there are other shows like solar system, inside of darkness, and different kind of names of the shows.
But no flash.
The astounding,
Confounding!
the drums will all be pounding. Kabooby Ruby.
Step right up and have your fortune told. The amazing Madame Luna tells all, yells all, and smells all.
It's those flying light bulbs.
Thank you.
Already, the Large Hadron Collider has made an incredible discovery that lends weight to our story. Not that long ago, there were fireworks at CERN on a recent 4th of July as scientists announced the discovery of a particle called the Higgs boson. Physicists had searched for this particle for 50 years, ever since theorists showed that the source of the mass of all fundamental particles requires its presence. Particles like electrons and quarks get their mass when they pass through the Higgs field. And so might the particle that makes up dark matter. Now, the search at the Large Hadron Collider turns to finding the dark matter particle itself. Astrophysicists have demonstrated that over 80% of the mass in the cosmos consists of dark matter. This is the amazing story of how we discovered that most of the matter in the universe is of an extraordinary, invisible type. A tiny fraction of a second later, energy transformed into the first particles of our universe. Tiny particles called quarks formed protons and neutrons. These combined with electrons to create the first atoms. Atoms, in turn, make up regular matter, the substance of which physical objects are made. As conditions cooled and space expanded, dark matter's mass coalesced into strands. These strands formed an invisible skeleton in space. Over hundreds of millions of years, the gravity from dark matter's mass was so powerful, it pulled regular mass to it, like meat to its ribs, and formed the sinewy structure of the universe. The first galaxies grew at the intersections of these filaments. Galaxies collided with other galaxies and merged again to form superclusters of galaxies. Countless galaxies were drawn together by dark matter's pull. And from there, they grew into the structure of the universe we see today. Without dark matter, there would be no stars, no galaxies, no planets, no life. Without dark matter, we ourselves would not exist. Dark matter lay hidden from human view for millennia until finally, traces of its influence became apparent to astronomers. The first was Fritz Zwicky, a Swiss astronomer who worked at Caltech in the 1930s. Zwicky turned his telescope towards a group of galaxies not too far from our own Milky Way. This swarming network of over 1,000 galaxies is known as the Coma Cluster, and Zwicky's mission was to determine its mass. He could do this by measuring its brightness, and by measuring the speed of galaxies orbiting inside the cluster. Zwicky discovered that the galaxies were moving much faster than he expected, especially considering the amount of mass in the cluster as indicated by brightness. At these speeds, the visible mass wasn't great enough to hold the cluster together. Zwicky theorized There must be some invisible substance lying in hiding, holding the speeding galaxies into the cluster. He called the substance dark matter. But some ideas are ahead of their time. Zwicky's revolutionary findings went largely unnoticed until 40 years later, when astronomer Vera Rubin studied the orbital speeds of stars in galaxies. What she observed surprised and confounded her. According to Newton's law of gravitation, the Sun's powerful mass creates a gravitational pull that causes the inner planets to travel at faster speeds than planets that are further out. Since stars orbit around a galaxy's center much the way planets orbit the Sun, Rubin thought she'd see similar speed patterns when she observed the nearby Andromeda galaxy. But what she saw was radically different. Stars that were in orbit far from the galaxy's center were whizzing along at high speeds, identical to the stars much closer in. This was not at all like the speeds of planets in our solar system, where the inner planets go much faster than the outer planets. At these incredible speeds, without adequate gravitational pull from something massive, the stars should fly out of control and jettison out into space. Something together. What could it be? Rubin and her team concluded that there must be some strange, invisible mass that extended to the outer edges of the galaxy and beyond. It was as if an invisible cloud held the stars together like a kind of glue. We can see visual evidence of these dark matter halos in other parts of the universe as well. We see the most dramatic evidence for dark matter in a celestial structure astronomers refer to as the bullet cluster. When astronomers looked closely at galaxies in the cluster, they saw subtle distortions caused by something invisible. This is the entrance to the Homestake Mine in South Dakota. It's the ultimate place to filter the dark matter particles out from the rest. In order to isolate the dark matter particles, physicists conduct experiments deep underground where most ordinary particles can't travel, but dark matter particles easily can. Every morning, dozens of scientists travel down a giant elevator shaft 1,500 meters underground. That's almost a mile, to work with the most sensitive dark matter detector in the world. What they find in this subterrestrial labyrinth of abandoned mining tunnels could change the way we view the entire universe. This was once a thriving gold mine. But now, instead of miners mining for gold, the physicists who work here are mining for an even more elusive substance: dark matter. This is the Sanford Underground Research Facility. It's here that we'll find the Large Underground Xenon Dark Matter Experiment, or LUX for short. This tank filled with liquid xenon will be the perfect theatre for witnessing the first appearance of a dark matter particle. bait for detecting the dark matter particle will be the nucleus of a xenon atom. When a dark matter particle hits, the nucleus will give off a flash of light or release electrons. These interactions will then be recorded by sensors on the bottom and top of the detector. Dark matter interactions of any kind are rare, but physicists hope they'll see one very soon. On the other side of the world, another group of physicists is working on creating their own dark matter particle. They're doing it here, at CERN, the world's largest research center for the study of particle physics, located outside Geneva, Switzerland. Track down answers to humankind's most complex and age-old questions concerning the nature of matter. Hidden beneath CERN's sprawling 450-acre, 2-square-kilometre campus and the surrounding forests and farms of the European countryside lies the biggest and most complex machine in the world, the Large Hadron Collider, otherwise known as the LHC. Inside it, 2 beams of protons travel in opposite directions around the ring at incredible speeds. The protons then collide inside 4 gigantic detectors. The LHC is a giant particle racetrack. Instead of fuel, these subatomic racers are accelerated around the track by electric fields and steered by high-powered magnets. The particles are then guided towards collision in the core of each detector. The largest detector is appropriately called Atlas. It weighs 7,000 tons and took 15 long years to build. Engineer invented a thing called the World Wide Web in order to share this kind of information. With all this brainpower looking for dark matter and exploring the fundamental nature of our universe, who knows what they may find? Ultimately, it's the big questions that bring humankind closer together as we strive to understand the workings of this vast universe and our place in it.
Small show lasting just 25 minutes. What amazing, amazing. So in Moon my weight is 15, Neptune 101, Uranus 80, Saturn 82, Jupiter 213, Mars 34, Earth and 90 kgs. That's amazing location. Your weight on the planets. This is a view of Qatar village at night. As you see. So my thought about the place. This place is good. Small planetarium in the Qatar village. Nice place. Now, as I got, there is many places to visit in a row. Few museums and other places. Just we started with the planetarium. Oh, someone's birthday. What I like most in Qatar, that there are respect for all religions, because I've been staying here like more than 1 month. Now it's time to catch the train in the metro. Let's go. Main thing, do not forget to follow my channel. Yeah, this is just the beginning. I'm gonna travel all around the Qatar, visit all places like you and me. We will explore all of this beautiful, amazing country. How we changed it in the last just 20 years. Follow me. And this is not end. This is just the beginning.